So after an overview or introduction to EIGRP, let's go into a little bit more detail on this Eigrp metric and the process that a router uses to actually discover and build an Eigrp neighbor relationship. So, first of all, don't freak out, don't worry, you are not going to be expected to memorize this formula, okay? So, neither at the CCNA nor the CCNP level will they expect you to have this formula memorized. But this actually is the formula used by Eigrp to come up with its distance value. Now, take a look at some of these things. All of these values, for example, if I tell Eigrp, all right, you got a fast Ethernet interface here that's got the 111 network on it. I want you to activate that interface. I want you to start speaking Eigrp, and I want you to take that directly connected network and advertise it to your neighbors. Well, what Eigrp is going to do is he's going to look at that interface. And let me go over here to a router here for just a moment so you can see. So for example, if I go to router 1, show interface fast Ethernet 00. So if I tell Eigrp by using the network command that I want to activate on this interface and I want to advertise the 111 network, in order to come up with a distance value for this, he's going to take the bandwidth, the delay, the reliability, and the load. He's going to take those values and plug them into this formula. So that's where these values are coming from: bandwidth, delay, reliability, and load. It's actually coming from the interface itself. Every single interface on a router or a multi-layer switch has values for these things. Now, what are these K values? The K values are just multipliers, things to multiply against this. So notice the default values of the K values, some of them are 1 and some of them are 0. So for the K values where the default is 0, like K2 and K4 and 5, well, that means, as it says, this part of the formula here doesn't have any meaning if those numbers are 0. So this part drops out, and this part of the formula also doesn't have any meaning if K2 is 0, so this part drops out. So because of that, we end up with the metric being 256 times whatever the bandwidth is plus the delay. So bandwidth plus delay times 256 is what Eigrp uses as its distance. Now it's a little bit more complicated than that because, for example, bandwidth is a scaled number. In other words, I'll just do this down here. If my bandwidth, and you don't have to memorize this, so don't worry about that. If my bandwidth was something like that in kilobits per second, Eigrp will actually take that and divide it by some number. I don't know what it is. I think it's like 10 million or something like that. I'm not sure what it is. But it basically divides that. So the larger this bandwidth becomes, the smaller this overall number becomes. So that's what I mean by it's a scaled number. It's an inverse ratio. Don't have to memorize that. Main takeaway that I want you to have from this was that with the default K values, reliability is not part of the formula and load is not part of the formula. The only factors that go into the formula are delay and bandwidth, and that's it. Now, what you do need to know, though, for the CCNA is this next section. The delay is the sum of the delays along the path, and the bandwidth is the lowest bandwidth of the link along the paths. What does that mean? Well, that means this. Let's imagine for a moment that I have some routers here. So router 1, 2, 3, 4, and 5. And we'll just put some connections from them. And we're going to start out with router 1 advertising network X, whatever network X happens to be. So the way router 1 is going to do this is I'm going to use the network command under my Eigrp process to say, hey, network whatever X is. So router 1 will take a look at this interface, his interface that goes upstream or leads to that network. And because he's directly connected to it, He's going to come up with some bandwidth value. Let's say the bandwidth here is 3,000. And he's going to come up with some delay value. Let's say the delay is 10. Now, since that's all he has to work with, that's what he's going to send downstream. So in an EIGRP update to router 2, he's going to say, the bandwidth I used in my calculation was 3,000, and the delay I used was 10. Now, router 2 is going to say, okay, great, but I need to factor in what's my upstream bandwidth. So on this interface I used to get to you, what's my bandwidth and delay along this way? Now let's say that he says, okay, my bandwidth on this interface right here is also 3,000. Let's just say it matches. And he says my delay is equal to 5. Then for router 2, when he plugs these numbers into his formula, he's going to take the lowest bandwidth, which in this case they're both the same. So he'll use the bandwidth of 3,000 and he'll do the sum of the delay. So in his formula he'll put in the number 15 for the delays. Now let's keep going. Now he decides to send an EIGRP update to router 3. Router 3 gets it. He says, okay, let me take a look at my interface because I have to factor in this link right here between us. He says, oh, okay, router 2, you told me that the lowest bandwidth that you're aware of is 3,000. However, my bandwidth leading up to you is only 500. And my delay is an additional 10. So from router 3's perspective, when he comes up with his metric in that nasty formula that we saw, he's going to plug the number 500 into the bandwidth column because it's the lowest bandwidth along the path. He's going to ignore these 3,000s. He's going to take the weakest link in the chain, the lowest bandwidth. And then the sum of the delays at this point will be 25. 10 plus 5 plus 10. And that's what happens as we go along on each path. Each router is going to say, okay, what bandwidth is my neighbor telling me about? Is my bandwidth leading to him lower than what he's telling me? Because if it's lower, I'm going to swap his number with my lower number. Because all I care about is the slowest bandwidth along the path, not the fastest bandwidth, the slowest bandwidth. And then what's the total delay my neighbor is saying it takes to get to that network? Well, let me add that into what my delay is to reach that neighbor. So that's why we say here on this slide that the delay is the sum of delays along the path and the bandwidth is the lowest bandwidth. That is something you do need to know. They're not going to expect you to know the formula, but they will expect you to know those bullet points. Also, as far as K values are concerned, they want you to know what K values are. In other words, they want you to know that, okay, K values are just numbers that are multiplied against things inside the formula. They're not going to ask you, okay, K2, what's that multiplied against? K4, what's that multiplied against? They're not going to expect you to know that. But they will expect you to know that K values are just multipliers against this.